Yeah, welcome to continuation of our definitions or explanation of topological manifold, where today we are going to define what we mean by second countable space. So we take a definition and possibly an example, okay? Now a topological space X tau is said to be second countable. Okay? Okay, so O is said to satisfy the second axiom of countability. So it is said to be second countable, or in other words, it is said to satisfy the second axiom of countability, because we have first axiom, second axiom, and so on and so forth. If it has a countable basis. Okay, so that means second countability axiom requires a topological space to have what we call countable basis. Okay, so in other words, it means X tau is implied that the space X tau is second countable. If for any there exists, okay, for any you pick an open set in tau, there will exist some union I maybe from 1 to m of some bi, where each bi is in the basis. And of course, the basis itself is required to be countable, meaning that B is equal to set of Bn, n in n. So you index n in the set of natural numbers. That means you make it countable. So the basis here is countable. And every open set you pick in tau, that open set can be written as union of some basis. This is what we mean by it has countable basis. Okay. Now there are several examples of second countable space. Okay. The best of which is the Rn itself. Okay. The Rn, the n-dimensional Euclidean space. Okay, endowed with the usual topology of open sets. So you have Rn and maybe tau I, okay, or tau usual topology, which is tau here is the standard topology. Now the bases are the Bi, the balls, okay, centered at X. So what you do is you now index the balls for the basis, and they make the radii to be, so you have a ball, for example, center X and radius Ri, where Ri are in Q, the rational numbers. So you index the radii of the balls. in the set of rational numbers. That means the basis will be countable. So any open ball you pick in Rn, that open ball can be expressed as a union of these radii. This is one of the best example of a second countable space. So welcome to next presentation.